Hello and welcome to Saurav Sir's classes. Today we'll learn about the Archimedean spiral. Now the term spiral is used to describe a geometrically smooth curve. It's a smooth curve which winds about a central point. Winds about a central point, while it also recedes from it. It recedes from the central point gradually. Right? So what is the Archimedean spiral? The Archimedean spiral is the simplest form of a spiral, and it was made by Archimedes on his book The Spirals. Right. So how do we go about constructing the definition? The definition states that a curve whose equation in polar coordinates is r equals a theta, where a is greater than 0 and this is a constant. Right. So we can generalize this equation in the form of r equals a plus b theta. Please remember, this is in the polar coordinates. So what do we do when we need to transfer to Cartesian coordinates? In Cartesian coordinates, the x component equals r cos theta and the y component is equal to r sine theta. The transformation allows us to write the Archimedean spiral's equation in a parametric form, where the x component is equal to a plus b theta cos theta, and the y component is equal to a plus b theta sine theta. Now it is necessary to decide the set of parameters that will define the spiral geometry. So how do we go about defining a initial and the a final? We need to define these, and we need to define the desired number of turns, which is n, and spiral growth rate, which is b. So we can write the equation as b is equal to a final minus a initial by 2 pi n. Further, we need to decide the spiral start angle theta naught and the end angle theta final. Now let's begin with the values of theta naught. Theta naught is equal to 2 pi n, and theta naught is 0. Let's just erase this here. Naught is 0, and theta f is equal to 2 pi n. So I'll just show you how this looks like in polar coordinates, since constructing in Cartesian is not possible here. It sort of looks like so, and this is O, this is A, and this is B, and here A equals A theta, right? And here we see that OA is equals to A pi and OB is equal to 2A pi, so OB equals to 2OA, right? These are the calculations required, and sort of more if you are constructing in a precise manner in Cartesian coordinates. So you will need to do a lot more, including thickness and let's say how much the curve thickens with every turn. You will have to do a lot more calculations than this, so it is much more easier to construct in polar coordinates than it is in Cartesian coordinates. That's it. Thanks for watching.